In this class, we solve a problem of dynamics or mechanics from the chapter Motion in a Plane in Cartesian Coordinate. Now, the problem is a particle moves in a plane under a force which is always perpendicular and towards a fixed straight line on a plane or on the plane, its magnitude being mu by distance square, and if initially it be at a distance 2a from the line, be projected with velocity root mu by a. This is the initial velocity of projection parallel to the line. Prove that the path traced out by it is a cycloid. We have to prove the path is a cycloid. Okay. Now, for the motion in a plane, we take these two are x-axis and y-axis. Okay, x-axis and y-axis. This is origin, and here it is says that if initially it be at a distance 2a from the line means the line of x-axis, because which is always perpendicular towards the fixed straight line, and we say here the force is always perpendicular to the fixed straight line. This is x-axis. Okay, so the initial point of projection is a. This is at a distance 2a from the origin, and the coordinate of a is obviously 0, 2a, right? And we project the particle as like this. Okay, let P be the any point whose coordinate is xy and at any time t. So the force is always directed towards the fixed line, that is the fixed line is x-axis, and the force is given by mu by distance square means y square, because the distance of P from the fixed line is y, and since this force try to decrease the value of y, so this is also negative force, or we say that this force is perpendicular and towards the straight line, so this is negative force. Okay, and here the initial velocity, this is parallel to the fixed line, and the initial velocity is mu root mu by a square, root mu into a, and this is obviously x dot, because this is the only velocity parallel to x-axis. There is no velocity parallel to y-axis. So initial velocity along y-axis, this is y dot, this is equal to 0. This velocity can be used as an initial condition to find out the integrating constant. Now, if we take m be the mass of the particle m, then the equation of motion of the particle at any time t is given by m x double dot, this is equal to 0, because there is no force along x-axis, and the second equation of motion is m y double dot, this is equal to minus m mu by y square, because this is the force per unit mass of the particle. Clear? So we integrate this relation and get x dot, this is equal to constant c, and if we put initial condition, that is x equal to 0, y equal to 2a, and x dot equal to this, we get root mu by a, this is equal to c, that is we get x dot, this is equal to root mu by a. Now again integrating this relation, we get dx, this is equal to root mu by a into dt. So we get x, this is equal to root mu by a into t plus another integrating constant d, and the initial condition is x equal to 0, y equal to 2a, t equal to 0, x dot this is equal to root mu by a, and y dot this is equal to 0. These are the initial condition. And put x equal to 0 and t equal to 0, we get d equal to 0. So we get a relation x this is equal to root mu by a into t. This is an important relation to find the curve. Now from the second equation of motion we multiply both sides by 2y dot. Okay, so 2y dot into y double dot, this is equal to minus 2 mu y dot by y square, and this relation gives ddt of dy dt whole square. This is equal to minus 2 mu by y square into dy dt, and integrating we get integration d of dy dt whole square. This is equal to minus 2 mu by y square into integration dy dt whole square. This is equal to 2 mu by y plus integrating constant e. Right? Now put the initial condition y dot this is equal to 0, where y this is equal to 2a, and we get e this is equal to 2 mu by 2a, that is mu by a. Right? And we put the integrating constant here, and we get dy dt this whole square. This is equal to 2 mu by y plus mu by a, and taking common 2 mu we get this is 1 by y plus this is 1 by 2a. Right? And this is not mu by a, this is e equal to minus mu by a. Sorry, this is a mistake, because e this is equal to minus 2 mu by 2a, so we put here minus mu by a, and this is also minus. Now if we get dy dt, this is 2 mu by 2a this root, and this is 2a minus y by y. We take here a negative sign, because the y is decreasing when t is increasing, because if the particle goes through the end point, then y continually decreases but time increases, so dy dt must be less than 0. So we take here a negative sign, and we cancel out 2 and 2 here. Now by changing the side, as now to integrate this relation, we put y this is equal to 2a into cos square theta. Right? And here this is the initial position. If we put y this is equal to 2a cos square theta, then the initially y this is equal to 2a. So if at t equal to 0 y equal to 2a, then we must get theta this is equal to 0, because cos square theta this is equal to 1, so theta this is equal to 0. And in general point, that is in the point P, y equal to y, this means theta equal to theta here and t equal to t here. This is the initial point, t equal to 0 and theta equal to 0. That taking limit of t and taking limit of theta and putting the value of y, this is equal to 2a cos square theta, and dy this is also 4a cos theta into sin theta into d theta, this is minus. We get from this relation as root mu by a into t, limit 0 to t, and the right side is minus integration 0 to theta, and this is root 2a cos square theta by 2a minus 2a cos square theta into minus 4a cos theta sin theta d theta, and we get minus minus plus, so this is 4a integration 0 to theta, and this relation gives cos theta by sin theta into cos theta into sin theta d theta. Sin theta cancel out, and we get 2a into integration 0 to theta. This is 2 cos square theta, means 1 plus cos 2 theta d theta. By integrating, we get 2a into theta plus sin 2 theta by 2, because theta and sin 2 theta both are 0 at theta equal to 0. Now we put this relation root mu by a into t, this is equal to x, because we get already a relation x equal to root mu by a into t, and the right side is x equal to a into 2 theta plus sin 2 theta, and another relation y, this is equal to, we put this relation and we get y, this is equal to a into 2 cos square theta, means 1 plus cos 2 theta. Now if we put 2 theta, this is equal to phi, so we get x, this is equal to a into phi plus sin phi, and y equal to a into 1 plus cos phi, and this is the parametric equation of cycloid, with a be the radius of generating circle, right? And so we prove that the path traced out by the particle is a cycloid whose generating circle radius is a. Okay, this is the complete solution of the problem. Okay, thank you for watching.